Welcome to the Maths Made Easy tutorial on probability and tree diagrams. This is the second video on this topic, so if you've not seen the first one yet, go check that out. In the first video we covered independent and dependent events. This one will talk about tree diagrams. So first off, let's start with an independent or two independent events. And the two events that are in question are rolling two dice, or dices if you like, and let's say we're interested, as before, in the probability of rolling a 6. So the structure of the tree diagram will be as follows. We start from a single point, and there are two outcomes for each event. Now when I say event, what I mean is each roll of the dice, and the two outcomes in question are we either roll a 6 or we don't roll a 6, since that's what we're interested in. And then for the second event, it's the exact same, but we just build two separate branches now. So that is 6 or not 6 again, and 6 or not 6 again. So as you can see in the diagram, every possible outcome over the two different rolls of the dice is included. Now let's add a couple more things to the diagram. Let's just add some labels. So this is the roll number 1 and this is roll number 2. Now all that's left is to add the probabilities in. Now because there's 6 numbers on a dice, we know that the probability of rolling a 6 is always going to be 1 out of 6, and then the probability of not rolling a 6 is therefore 5 out of 6. And that's the same for both rolls, seen as though we're dealing with independent events here. So in other words, the probability of rolling 6 on the second throw is not affected by the probability of rolling a 6 on the first throw. So it's always 1/6 for the probability of rolling a 6 and 5/6 for the probability of not rolling a 6. And then if you fill out all the different probabilities, you should get the same tree diagram as the one I've drawn here. So let's move on to some dependent events now. So in this instance, let's say we're interested in the probability of withdrawing a blue sweet from this bag of sweets. So event 1 will be taking the first sweet out of the bag and then not replacing it, and then event 2 will be taking the second sweet out of the bag. So our outcomes are as follows. So it can either be blue on the first take, or it can be not blue, so that would be red. And then on the second sweet, it will either be blue again, or it will be red. And that's the same for both instances, regardless of the outcome of the first event. So let's add some labels. So that's sweet number 1, the first event, and then the second event is sweet number 2. Now all we have to do is add the probabilities. Now if there's 5 sweets in the bag to begin with, and 2 of them are blue, then the probability of taking a blue sweet is 2/5. And then after that, if you take a blue sweet out of the bag, there's only 1 blue sweet left, so the probability will be 1 out of 4, seeing as though 1 of the 5 sweets is gone. And then for a red sweet, if the first one was blue, the remaining probability will be 3 out of 4. And that makes sense, as there'd be 3 sweets that are red left out of a total of 4 sweets. But then if we go to sweet number 1 again, the probability of taking a red sweet out is 3/5. As you can see from the bag, there's 3 red sweets out of a total of 5 sweets. But then if the first one is red, the chance of taking a blue sweet out on the second one is 2 out of 4, as the 2 blue sweets are still in there, but the total number of sweets is now 4. And then also that'll be the same for all the red sweets. Now I could have left these, I could have changed these probabilities to a half, because that's the same as 2 out of 4, but I think it's easier to visualise if you have 2 out of 4. So that's a perfectly fine way of leaving your probabilities there. If you want to get some practice with some tree diagrams exam style questions, then you can have a go at our online exam. It's available through our revision platform, and there's loads of different questions to have a go at. You get instant feedback on all of them, and you'll see the solutions and find out where you need to improve, find out where you went wrong, and so on. So if you're interested, then you can click the link below, it will take you straight over there.